No.
Interesting.
Natural logarithms and common logarithms.
Excellent. That's exactly the answer I wanted. Natural logarithms and common logarithms. Natural logarithms have a base of e. Common logarithms have a base of 10. That's it. That's all they do. So what you need to understand is you can rewrite any log that you see as one of those two things. For example, in number 4, I see log base 3. Can our calculator do log base 3?
No.
No way. But I can do this. Or I could do this. And both of them are exactly the same. Doesn't matter which one you use. That's kind of the cool thing. I usually use ln. I don't know why. Maybe because of the French name. Log natural.
Wait, ln's the natural. Okay.
Oh man, this is confusing. There are logs in these problems.
Oh no.
But there are some things that are not confusing. Like I see a square. And if I don't want a square, I square root. Ha ha! So I square root. And if I square root, on the left side I get log base 2 of x. Because the square and the square root cancel each other out. They're inverses. Yeah, and then the square root of 16 is 4. Except if you write it like that, you're wrong. Because I square rooted a
Plus or minus.
variable, so I have to have plus or minus. So this really means there are two separate problems that are occurring for us. The two separate problems that are occurring for us are that I have the log base 2 of x equal to 4. And the other problem that's occurring is that I have the log base 2 of x could be equal to negative 4. Those are the two problems that are happening. Whoa! Can my calculator do log base 2?
No.
No, but yesterday we learned something really cool. We learned that logs are really
Opposites of exponents.
our exponents.
Or
Remember Ben?
inverses.
Yeah.
Yeah? Me, I remember him too.
That was Bert.
Ben. Base the exponent equals the number. One of my answers is 16. If you don't know what I'm talking about, go back and look at your notes from yesterday.
Okay.
Second one, Ben again. One 16th. In B, that I have 2 to the 16th power equals x squared. Holy moly. 2 to the 16th I can't really do in my head. That's just too much. Oh, I don't have to do that.
Divide the exponent.
Don't divide the exponent. Square root it.
So it goes to.
So let's square root the exponent. So I square root both sides. I get x equals plus or minus. Oh, that's unbelievable. Sorry. Unbelievable. What does square root mean the same as?
1/2.
1/2 power. And half of 16 is 8. So this is really talking about 2 to the 8th power. And I don't know what 2 to the 8th power is, but I do know what 2 to the 4th power is, because we just did it. 2 to the 4th power is 16. And I've actually memorized my squares up to 25. So I know 16 squared is 256. So this is plus or minus 256. You can actually do it on your calculator if you wish.
Oh, I just don't have
Big dummy. You guys, all of us are at different places. Some of us takes a little bit longer to comprehend some things. We're all going to reach a plateau somewhere. It's okay. We just do our best. That's all we do. Holy moly. What is crazy about letter C?
Oh,
Crazy.
2 logs.
2 logs! That's bugging me. I'm not going to do 2 logs. Oh, look! The 2 logs are being added, which is really the same as
Multiplication.
multiply.
Hey.
Yep. Just, here we go. That's really like 1 log with a base of 5. And I'm going to multiply those 2 things. And that's going to be equal to the 4 now. Or in other words, I condensed the left side. Secret code in math. Next, I'm going to simplify this just a little bit. So now instead of writing it that way, I'm going to write it as the log base 5 of x squared minus 9 equals 4. What did I just do? I FOILed.
You a king.
Yes. I did. Oh, look, it's a log. I have no idea what to do. I think I'm going to change it to Ben. Base to the exponent equals the number. Whew, this makes a lot more sense to me now. I don't know 5 to the 4th, but I do know 5 squared. What's 5 squared? 25. And 25 quarters is the same as $6.25. And then, that's the same as x squared minus 9.
And now you add 9.
And now we add 9 to both sides. Somebody else get the door. I'm busy. 625 minus 9 is the same as, plus 9. 634. And that's equal to x squared. And the last step that I have to do is square root both sides. So I get x equals plus or minus, and I have no idea what that number is. About 25? 25.18? And whenever you deal with things like square rooting, especially in logs and exponentials, you should always check your answers. Don't forget to always check your answers. We're not going to have time for that right now. But go back and plug it in and see if it works. In the original expression. Go back, plug it in, and see if it works. So as I look at this problem, what we just said is, I notice that if I have a 3 to some power like x, and that's equal to 3 to some power like 7, then I know that my x is 7. So I'm going to use that same strategy. So I see 3 to the 2x here. And 243, if you start checking, you find out it's 3 to the what?
5th.
It is?
Yes.
All right. 5th power. Oh, look, the bases are the same. That tells me that my exponents have to be the same. Or in other words, 2x is the same as 5, which means x is 2.5. In E and F, they both have different bases. And like with the 3 to the whatever and the 243, I might try to get the base to be the same and then have an exponent. But in this case, I can't do that. So this is kind of the question that Mason was asking earlier, like what if I'm screwed because the bases are different? So here's what happens. One of the things that we taught you today is a strategy that's going to help you with these things when the bases are different. When the bases are different, here's what you do. Log both sides. When the bases are different, log both sides. I would write myself a note. When bases different, log both sides. Why did I pick natural log?
How do you like it, French?
French name. I like it better. There's no, you can use LOG, I don't really care. So maybe this didn't make sense to you, like why I said what I said, but here's the deal. Now that I look at log, the reason you can log both sides is I can add 5 to both sides of an equation. I can multiply both sides of an equation by 7. I can square root both sides of an equation. And like I can do any of those things, I can also log both sides. The reason I'm logging is there's a rule in logs. What's this rule?
Multiplication and
No. I'm looking for one word that starts with a P.
Power.
Power. It's a power rule. You can pull the power down and make it multiplication. So now I rewrite it like this. 3x minus 1 log. What's happening between the 3x minus 1 and the log? Multiplication. Very good. Multiplication. Log 5 equals, parentheses, 2x plus 1, parentheses, log 7. Ready? Grab your calculator. What is the natural log of 5? To 3 decimals.
1.609. 1.609.
1.609.
1.6.
1.609.
1.6.
Are you sure?
Yes.
1.609?
Yeah.
Yep.
Okay. 1.609. How about, what is the natural log of 7?
1.9.
1.946. Take a look at those. Now I have a number on the outside of parentheses. What should I do on the left side and the right side? Starts with a D. Distribute. Yep, good job. So I distribute these numbers. And then after I get done distributing these numbers, I solve the equation. When you get done solving this equation, you should get an answer, and I'm not going to do it for you because if you can't do that, that's another help session for you after school. I get 3.798 roughly. So on your own time, I would like you to try to solve that equation. There are no more logs involved. This is a simple algebraic equation. I would like you to do that on your own.